Good morning, students. यश आवाज येतोय?
हो सर.
स्क्रीन विजिबल?
हो सर.
ओके, सुरू करू आपण. काल आपण मॅक्सिमम वर्क डनचं एक्सप्रेशन बघितलं. याची प्रॅक्टिस करा. खूप वेळा परीक्षेला आलेले बरं का हे एक्सप्रेशन. मी अजून एकदा सांगतो. W max is equal to -2.303 nRT log to the base 10 V2 upon V1 and P1 upon P2. हे दोन एक्सप्रेशन्स पाठ करून ठेवायचं. हे बऱ्याच वेळा 3 मार्काला विचारलेले आणि ह्या वर्षी पण विचारण्याची शक्यता आहे. त्याच्यामुळे हे एक्सप्रेशन पाठ झालं पाहिजे. Then internal energy, this part is also completed. Once again, I will explain what is mean by this system's internal energy. This energy, every substance is associated with a definite amount of energy. So this amount of energy, it is stored in the substance. It is called as internal energy. Each substance having its internal energy, but it always changes. And internal energy of every substance, it is different. So internal energy, it is nothing but it is the sum of kinetic energy and potential energy of all the particles of the system. All the particles means atoms, molecules, ions are included. So this internal energy, when the energy is transferred as a heat or work from the system, the internal energy will be changes. When energy is transferred to the system, internal energy, it will be added. And when energy is transferred from the system, then we have to subtract the internal energy. We also discussed these two statements yesterday, when the internal energy will be added and when the internal energy will be removed. So these three examples yesterday I have explained. When the internal energy is added, when we have to do the addition, and when we have to do the subtraction. So subtraction is done when system releases energy. When energy is provided to the system, then internal energy will be increases, internal energy will be added. But when the energy will be released from the system, the internal energy will be decreases. When work done by the surroundings also, the internal energy will be decreased. And when work will be done by the system, see here, work is done by the system, on the system, sorry, work is done on the system, then internal energy will be added. And when work will be done on the surroundings, internal energy will be means decrease. We have to do the minus here. So these three examples required when you are going to solve the numericals. And then we are discussing about this first law of thermodynamics. For the examination point of view, they can ask, write the statement of first law of thermodynamics. Remember, so we have to write all these three statements. All these three statements are related to the law of conservation of energy. Energy of the universe remains constant. The total internal energy, see, the total internal energy of an isolated system will be constant because there is no exchange of energy. So in case of isolated system, internal energy will be remains constant in all over the universe, remember. And energy neither be created nor be destroyed and can be converted into one form into another. These are the three statements of first law of thermodynamics. These statements also can be asked for 2 marks. All the statements are equivalent. Then this is the mathematical expression of first law of thermodynamics. This can be asked for 1 mark. So in case of mathematical expression for first law of thermodynamics, suppose Q is the quantity of heat supplied to the system. Means we are supplying quantity of heat to the system. W is nothing but it is the amount of work done on the system by the surroundings. Then the internal energy will be increased because we are going to supply the heat to the system. See, Q is the quantity of heat supplied. You means we are going to supplying the heat to the system, so the internal energy will be increased. So the internal energy increase in internal energy, it is given by delta U is equal to the Q plus W. So delta U is equal to the sum of Q, heat supplied, and work done on the system by the surroundings. And for the small changes, it is given if in one step by step. If one step, if the change occurs, it will be the du is equal to dq plus dw. This is the mathematical expression for first law of thermodynamics. It is the internal energy, change in internal energy is equal to q plus w. So remember, this can be asked for 1 mark. Then this is also very important for the examination point of view. Different first law of thermodynamics for these various processes we already studied about, this isobaric process, then isochoric process, isothermal process. But these processes with respect to first law of thermodynamics, this can be asked for 1 mark. If the question it is asked for the exam, explain the first law of thermodynamics for isothermal process, only we have to write down this much answer. So isothermal process, already you know about the isothermal process, means temperature is constant. If the temperature is constant, delta T is 0, then if the delta T is 0 means internal energy will be 0. So delta U is also constant. So first law of thermodynamics becomes, this is a statement of first law of thermodynamics. So delta U is equal to Q plus W. Delta U is already 0 because delta T is 0. Temperature is constant means internal energy will be 0. So put the value of delta U is equal to 0 in this equation, Q as it is, W as it is. So Q is equal to minus W, or W is equal to minus Q. This can be asked for the examination for 1 mark, and this is very easy. If temperature is constant, delta U will be constant, internal energy will be constant, and by putting these values, we can derive this relation, Q is equal to minus W or W is equal to minus Q. This is for isothermal process. Then next process is adiabatic process. In adiabatic process, there is no exchange of heat between system and its surrounding. It is called as adiabatic process. So in case of adiabatic process, Q is equal to 0. Q is equal to 0 because we are not exchanging heat. So Q is equal to 0. Then the equation of first law of thermodynamics is, this is the mathematical expression. Once again, I am repeating this: delta U is equal to Q plus W, where Q is heat supplied and W is work done on the system by the surrounding. So this expression becomes delta U is equal to W because Q is 0 here. We are putting the value of Q is 0. So delta U is equal to W, or minus delta U. Something is missing here. Delta U is equal to W minus delta U is equal to, this is not required actually. This is not required. Delta U is equal to direct W. We can put the value of Q is equal to 0 here. So in case of isochoric process, remember isochoric process means volume is constant. So the delta V is equal to 0. You already having this. This is the expression for mathematical expression of first law of thermodynamics. So delta U is equal to Q minus W. Already you know the in case of thermodynamics, the work done is pressure volume work. This relation we already derived. W is equal to minus P external into delta V. So just put the value of W in this equation, Q minus P external into delta V. Then we can write delta U is equal to QV, where this is a small v, where QV is the heat transferred at constant volume. Q is heat and small v is volume. So QV is the heat transferred at constant volume, where QV is also the state function. So we have to write this when it is asked for 1 mark. Delta U is equal to QV. So this is the QV means this is a heat transferred at constant volume. The same expression it is for isobaric process. In case of isobaric process, pressure is constant. In case of isochoric process, volume is constant. Directly we can write here delta H is equal to QP, where the new symbol is introduced in the thermodynamics, delta H, where delta H is the change in energy or change in enthalpy at constant pressure. It is called as delta H. So in detail we will discuss. This is the first law of thermodynamics, mathematical expression Q plus W. Pressure is constant. So putting again the value W, because this is the same expression, we are going to put the value of W minus P external into delta V, or you can write QP is equal to delta U plus P external into delta V. See here QP, Q is replacing Q by QP, where QP is the heat transferred at constant pressure. Remember, P, a small p is a pressure heat transferred at constant pressure, same like as QV. QV is heat transferred at constant volume. So QP is also same, heat transferred at constant pressure. So if Q is replaced by QP here in this equation, see, if it will be QP, then QP is equal to delta U. We have to shift this delta U into this right hand side. So QP is equal to delta U plus P into delta V. But this QP is a heat transferred at constant pressure. In thermodynamics, we are going to introduce a new symbol, delta H. So delta H, it is nothing but enthalpy change at constant pressure. So delta H is equal to the means QP. We are replacing this QP by delta H. This QP and delta H, it is same. That is the change in energy or change in enthalpy at constant pressure is equal to this as it is. We are not going to change any in this delta U plus P external into delta V. Delta H is equal to QP. Already I explained here. Delta H is equal to QP. Where QP is the heat transfer. This is also explained. So this out of this isothermal, adiabatic, isochoric, and isobaric, any two processes or any one process can be asked for the examination. Make a very important mark there in your textbook or in your notes. Then one simple numerical we will discuss, and the next part again uh, enthalpy we will start. In a particular reaction, 2 kilojoule of heat is released. Always remember, when you are going to solve the numericals, read the numerical very carefully. In a particular reaction, 2 kilojoule of heat is released. Means here internal energy will be decreased. Always we have to remember, heat is released by the system, means it will be not added. And 6 kilojoule of work is done on the system. Determine delta H and delta U. So we having the already we discussed about the mathematical expression for the first law of thermodynamics. Delta U is equal to Q plus W, where Q is the heat released here minus 2 kilojoule, because heat is released plus work is done on the system. You see here, work is done on the system. So according to the sign conventions, W will be positive. So by solving this simple equation, we will get delta U is equal to plus 4 kilojoule, means delta U is calculated. Then we already having this relation delta H is equal to QP, just we discuss here. In case of isobaric process, delta H is equal to QP. So it will be minus 2 kilojoule, because See here, delta H, it is the change in enthalpy at constant pressure. Here, in a particular reaction, 2 kilojoule of heat is released. Means we are removing the heat from the system. So here, QP is the heat exchange at a constant pressure. It is very simple numerical. Such type of numericals are not asked for the examination, but for the understanding purpose it is given when the heat is released, and just it is an example on first law of thermodynamics, that's why it is given. Then this is the enthalpy, it is the new concept. See, enthalpy means what? Enthalpy and energy, both the words are same. uh, Enthalpy of the system, enthalpy of the system, uh, it is defined as sum of internal energy of the system and energy due to the its pressure and volume. Always the definitions are quite difficult to remember, so remember this statement: H is equal to U plus delta V. By this equation we can prepare the definitions. Here H, it is stands for enthalpy. Enthalpy is equal to internal energy. U is internal energy plus it is the product of pressure and volume. Again, we will prepare the definition by using this expression. So, enthalpy of the system H is defined as it is the sum of internal energy and energy due to the pressure and volume. So the definition will be prepared by using this statement: H is equal to U plus PV. H is equal to U plus PV, where U is internal energy, P is pressure, and V is the volume of the system. Then change in enthalpy is given by change in enthalpy. It is delta H. H is enthalpy and delta H is a change in enthalpy. It is given by, it is H2 minus H1, where these are the two states, H2 and H1. H1 is the initial state and H2 is the final state. So the expression for change in enthalpy is given by, for initial state, H1, H1 is equal to U1 plus P1 into V1. As it is initial state or state number 1, we are writing H1 is equal to U1 plus P1 into V1. Then for final state, H2 is equal to U2 plus P2 into V2. This is for initial state and this is for final state. And the change in enthalpy, just we have to do the subtraction of H2 minus H1. So delta H is already written here, change in enthalpy, H2 minus H1. We having these two equations, H2 equation and H1 equation. Just we are going to put these values of H2 equation and H1 equation in this delta H equation. So H2 minus H1. H2 is U2 plus P2 V2 minus U1. This sign will be changed because we are doing here a subtraction U1 minus P1 V1. So by solving this equation, we will get U2 minus U1, this U2 minus U1 plus P2 V2, this P2 V2 as it is, and minus P1 V1. At constant pressure, P1 is equal to P2 is equal to P. So this expression becomes delta H is equal to U2 minus U1. It is a change in internal energy. So it will be delta H is equal to delta U. Delta U is nothing but change in internal energy. It will be delta U, U2 minus U1. And P1 and P2 is equal to P at constant pressure. The value of P1 is same, value of P2 is same. So it will be P into delta V, where delta V, it is a change in volume, V2 minus V1. See, V2 minus V1. So this expression is very important. It can be asked for the examination. Derive the expression for enthalpy change or change in enthalpy. Remember this expression delta H is equal to Many times this is asked for examination. Prove this equation. Delta H is equal to delta U plus P into delta V. That's why it is shown in bold color. You already know this QP is equal to delta U plus P external into delta V. This is a first law of thermodynamics for isobaric process. This one. See, this is the first law of thermodynamics for isobaric process. QP is equal to delta U plus P external into delta V. So, if P is equal to P external, then delta H is equal to delta H is equal to QP. Then this equation will be changed. Then this equation will be changed. Remember, if we are putting these values in this equation, QP is equal to delta U plus P external into delta V. Then this relation can be asked for 2 marks. Derive the relation between delta H and delta U, that is the change in enthalpy and change in internal energy. This can be asked for 2 marks. Many times this is asked for the examination. This expression is also asked, change in enthalpy. This expression is also asked for the examination. So we will discuss about this relation between delta H and delta U for the chemical reactions. At constant pressure, delta H and delta U are related as delta H is equal to delta U plus P into delta V. This is already we derived this equation. At constant pressure, delta H is equal to delta U plus P into delta V. P into delta V. This is the same equation we taken. Then for reactions involving solids and liquids, this delta V is very small because change in volume it is very small. Solids or liquids do not show change in volume with change in pressure. That's why this value delta V is very small. So in case of solids and liquids, as this is a small, delta H is equal to delta U. Then for the gaseous reactions, delta V cannot be neglected because change in volume you have to consider this delta V value is very important in case of gaseous reactions because the change in volume it is uh, cannot be neglected because this value can be more, not like solids and liquids. So again, this equation we are writing delta H is equal to delta U plus P into delta V is equal to delta H plus P into delta V. P into delta V, that is a V2 minus V1. V2 minus V1, we have to put this value of V2 minus V1. So this equation becomes delta U plus P V2 multiply this pressure PV2 minus P1. This is equation number 1, where V1 is the volume of the gas phase reactants and V2 is the volume of gaseous products. Applying the ideal gas equation again, PV is equal to nRT, where you know all these where pressure, volume, number of moles, gas constant and temperature. N1 is the moles for reactants and N2 is the mole for products. Same like volume, V1 is the gas phase for reactants and V2 is the gas phase for products. So P1 V1 is equal to N1 RT and PV2 is equal to N2 RT. So by substituting these values in this equation 1, we will get, we have to put these values P1, PV1 is equal to N1 RT. So delta H is equal to delta U as it is. We are putting this delta U as it is. Put the value of PV2. PV2 is N2 RT. N2 RT as it is kept minus N1 RT. So this N1 RT, it is the value of PV1. Again, by solving this equation, we will get N2 minus N1. N2 minus N1, this is a change in number of moles, that is delta N. And this is R is gas constant and T is the temperature. So this equation becomes delta U plus delta N in gaseous state and RT. So where delta Ng is the difference between number of moles of the products and those of reactants. Already we see here N1 is the reactants and N2 is the products, and delta N is, it is a change in a number of moles of products and reactants. So this equation again it is asked for the derivation for 2 marks. So this equation can be asked for 2 marks. Again, this equation can be asked for 1 mark. The screen is visible. Yes, anyone tell me screen is visible
Yes,
or
sir.
not?
Yes, sir.
Because the internet connection is not stable. So I think practice is required for this is very simple actually. Only we have to put the values. These derivations are not difficult. Only we have to put the values and solve the derivations. So remember this change in enthalpy, many times it is asked for exam. Delta H is equal to delta U plus P into delta V. So practice is required for this type of derivations. Actually, this is 2-3 steps derivations. In physics, you are solving many long derivations. In chemistry, only one derivation is very long. That is a maximum work done. Otherwise, all the no any derivation is bigger than that maximum work done. Only one derivation it is bigger. This is also the simple derivation. Only we have to put the values and what is expected to write. Whatever the notes I have given, only we have to write this much amount of matter. Don't increase the matter or don't delete the matter, because already I have short answers are very short. I make it very short. याच्यातलं काही कमी करायचं नाही, याच्यात काही ऍडिशन पण करायची गरज नाही. लक्षात घ्या, एवढंच जेवढं नोट्स मध्ये दिलेलं आहे तेवढंच लिहायचं. त्याच्यानंतर Ha, hey baga, these are the numericals depend upon this change in enthalpy. Delta H for the reaction, one numerical it is given here. This is a 2 marks numerical. Delta H for the reaction, one reaction is given, 2 carbons plus thrice H2 gas, it gives C2H6 gas. Delta H is given. This is the delta H of the reaction, minus 84.4 kilojoule at 25 degrees Celsius. So delta H is given, and what is asked? Calculate delta U for the reaction at 25 degrees Celsius. The value is given. Gas constant R is equal to 8.314 joule per Kelvin per mole. So first thing we have to write all the given things. Delta H is given, minus 84.4 kilojoule as it is. Then R value of R is also given, but it is yes, it is given in joule per Kelvin per mole. We can convert into kilojoule because this delta H is given in kilojoule. So this R also we have to convert into kilojoule, because this delta H into 10 raised to minus 3 kilojoule. And this derivation already we derived this derivation now. This one, relationship between delta H and delta U. Remember this derivation, delta H is equal to delta U plus change in number of moles, delta N G, and G for gaseous reactions, remember. And So we are going to put the values in this equation, but we have to calculate here number of moles from this reaction. We have to calculate number of moles. Delta Ng, it is the moles of the products minus moles of the reactants. So moles of the product, C, product is only one here. Number of moles is C2H6, only one mole, and uh, the moles of the reactant gaseous. Only we have to check the gaseous, not solids. So 3 moles are given here. 1 minus 3 is equal to minus 2 moles. So put this value minus 2 in this equation again. So put all the values. Delta H minus 84.4 is equal to delta U. Delta U we have to calculate. So delta U as it is plus put the value of RT. R is given. R is 8.314 into 10 raised to minus 3 kilojoule. This is the value of R into T. T is given in Celsius here, 25 degrees. We have to convert into Kelvin here. So 273 we have to add. It will be 298 into 2. This minus 2. How to calculate minus 2? Remember, see, moles of gaseous product minus moles of gaseous reactant. Don't take the moles of these solids. Only we have to check the gaseous. This is also gas. This is also gas. So all the values are already substituted. Then it is the mathematical part now. Now my role is completed here. My role is only to explain how to convert or how to substitute the values in this equation. Otherwise, mathematical part you can do addition, subtraction, and division. This is shifted to right hand side. So delta is equal to minus 4.96. Again, yes, delta is equal to minus 84.4 plus 4.96. So the final answer is minus 79. 0.44 kilojoule. This is a 2 marks numerical. Only we are going to put the values and mathematical calculations are there. So only one conversion is there. Maybe it may be asked for 3 marks or it may be asked for 2 marks. But most probably it will be asked for 2 marks numerical. So the same numericals cannot be asked. They can change the values. They can give the different reaction. But if you know the process, you can solve the any numerical. Then also we will discuss this numerical, calculate the work done. Work done. Yes. This work done in chemical reactions, again, it is the same like this equation. The work done by the system at constant temperature and pressure is given by. This is a thermodynamic work. Already you discuss about this thermodynamic work. W is equal to minus P external into delta V. Assuming P external is equal to P, so W is equal to minus P dV. Put these values in this equation according to ideal gas equation. So this equation is important. I want this equation W is equal to minus delta Ng RT. So again here delta Ng is a change in number of moles and R is a gas constant. Yes, Shubhangi, you raise your hand. See any doubt?
No, sir.
You raise your hand. That's why I am asking. इकडे बघा हे जे एक्सप्रेशन आहे त्याच्यावरचं हे न्यूमेरिकल आहे. तर पहिल्यांदा न्यूमेरिकल नीट वाचून घ्यायचं. कॅल्क्युलेट द वर्क डन इन ऑक्सिडेशन ऑफ 4 moles of SO2 at 25 degrees Celsius if the reaction is already given. 2 moles of SO2 gas plus O2 gas, it gives 2 moles of SO3 gas. Value of R is given. State whether work is done on the system or by the system. आता हे जर आपल्याला माहित नसेल वर्क कोण करते मग ते कळणार नाही, लक्षात घ्या. ती तुम्हाला मी साइन कन्व्हेन्शन्स मध्ये पण सांगितलं होतं, ज्यावेळेस सिस्टम वर्क करतं सराउंडिंगवर त्यावेळेस ते मायनस मध्ये असतं, लक्षात घ्या. एक्सपान्शन, ज्यावेळेस सिस्टम एक्सपांड होते त्यावेळेस वर्क डन सिस्टम करत असतं सराउंडिंगवर, आणि कॉम्प्रेशन मध्ये वर्क सराउंडिंग करत असतं सिस्टमवर. इथं काय विचारलंय तुम्हाला, स्टेट वेदर वर्क इज डन ऑन द सिस्टम ऑर बाय द सिस्टम. हे कसं कळेल, डब्ल्यूच्या साईन वरनं कळतं. डब्ल्यू जर मायनस आला तर वर्क सिस्टमने केलं, आणि डब्ल्यू जर प्लस आला तर वर्क सराउंडिंगने केलं सिस्टमवर. ऑन द सिस्टम लक्षात घ्या, बाय द सिस्टम आणि ऑन द सिस्टम हे दोन वेगवेगळ्या गोष्टी आहेत. वर्क बाय डन बाय द सिस्टम असेल तर डब्ल्यू निगेटिव्ह येतो, आणि वर्क डन ऑन द सिस्टम असेल तर डब्ल्यू हा पॉझिटिव्ह येतो, लक्षात ठेवा. तर आपण सोडून बघूया. फॉर ऑक्सिडेशन काय विचारले, हा आपल्याला फक्त विचारलंय की डब्ल्यू ची व्हॅल्यू काढायची आणि ती पॉझिटिव्ह आहे का निगेटिव्ह आहे बघायची. इथं बघा डब्ल्यू शेवटी बघायला मिळेल तुम्हाला. डब्ल्यू ची व्हॅल्यू पॉझिटिव्ह आहे म्हणजे डन ऑन द सिस्टम आहे, म्हणजे वर्क सराउंडिंगने केले, वर्क सराउंडिंगने केले सिस्टमवर, म्हणजे सिस्टमने वर्क केलं नाही. सिस्टमने जर वर्क केलं असतं तर हे मायनस आलं असतं, लक्षात घ्या. म्हणजे सिस्टमवरती वर्क केले, सिस्टमने केलेलं नाही. वर्क डन ऑन द सिस्टम म्हणजे कुणी केले, वर्क सराउंडिंगने केलेलं. तर आपण हे आपल्याला ऑलरेडी एक्सप्रेशन माहिती आहे, डब्ल्यू इज इक्वल टू मायनस डेल्टा एन जी आर टी. इथं आपल्याला काढायचे, हा हे नंबर ऑफ मोल्स बघा काढायचे आपल्याला. 4 मायनस 6, 4 मायनस 6 कसं आलं, एनीवन कॅन टेल मी. 4 मायनस 6 कसं आलं. समजतंय का बघा. इथं बघा, कॅल्क्युलेट द वर्क डन इन ऑक्सिडेशन ऑफ 4 मोल्स ऑफ SO2. ऑलरेडी इथं चार मोल्स SO2 चे दिलेले आहेत आपल्याला, आणि आपल्याला काय करायचंय, गॅसियस प्रोडक्ट मायनस, पहिल्यांदा काय करायचं, डेल्टा एन जी कसं काढतो आपण, मोल्स ऑफ गॅसियस प्रोडक्ट मायनस मोल्स ऑफ रिॲक्टंट. सो प्रोडक्ट मध्ये किती दिलेले आपल्याला, हे 2 मोल्स आहेत, आणि SO2 चे हे 4 आणि हे 2 असे हे 6. काहीतरी याच्यात गडबड आहे जरा.